Okay everyone, so this is my first try to make a video for you guys. Hope it works, and if it does then I will try to post more videos. So this video relates to chapter 7 as we covered in our class. So this is obviously MGTS 103, and what I'm talking about is my slides from chapter 7. So what I would suggest is kindly open chapter 7 slides as you go through this video, and what I would like to do here is go through the questions at the back of my slides, starting with question number 21. So question number 21 says, suppose a random sample of size 50 is selected from a population with sigma equal to 10. Find the value of the standard error of the mean in each of the following cases. Use the finite population correction factor if appropriate. And the first part is, it says the population size is infinite. Now, of course, what we are given in the question is sample size is 50 and sigma population standard deviation is 10, and the population size is infinite. So the standard error we're going to calculate with this formula: sigma divided by square root of n. Sigma is 10, n is 50, so square root of 50. So the answer would be 1.41. Okay, so part B is population size is 50,000. Now we can see if we need to calculate the correction factor or not. So we know that small n divided by large N is equal to 50 divided by 50,000. So this is equal to 0.01, and since this is less than 0.05, we can still use the same formula. Sigma x bar is equal to sigma divided by square root of n. So this is 10 divided by square root of 50. So the answer is 1.41. So part C, if you try, you would still get the same answer. It would still be the same, sigma divided by square root of n. So 10 divided by square root of 50 is equal to 1.41. Now part D is going to be different, and I'll tell you why. Because the population size n is now 500, so small n divided by large N is equal to okay, I'm just opening my slides here on my other computer. So small n divided by large N is equal to 50 divided by 500. This is 0.1, which is more than 0.05. So now we have to use a correction factor. So sigma x bar is equal to sigma divided by square root of n times the correction factor, which is large N, minus small n divided by large N minus 1, equals 500 minus 50 divided by 500 minus 1. So this is 500. And then, of course, sigma divided by square root of n, we've already found it to be 1.41. So then the answer is 1.34. Okay, let's move on to the next one. So the next question is question number 29. I'm just opening it on my slides so that I can read it. So question number 29 is income tax return preparation fees. The CPA Practice Advisor reports that the mean preparation fee for 2017 federal income tax returns was $273. Use this price as the population mean and assume that the population standard deviation of preparation fees is 100. So we are given that the mean is $273 and sigma is equal to 100. Okay, so that's given to us. Let's look at the first part. It says, what is the probability that the mean price for a sample of 30 federal income tax returns is within $16 of the population mean? So sample size n is equal to 30. Now, since we are not given the population size, we are going to assume that it's an infinite population or large enough population that we don't have to then use the correction factor. As I said in the class, that in most cases we would assume that the population size is infinite. Okay, so now within 16 means what we need to find out is probability that x bar is, so 273 plus 16 is 289 and 257. So what is the probability that x bar is between 257 and 289? So if this is our normal distribution and this is the mean 273, then 289 will be here and then 257 will be here. So we are going to find this area. So this is x bar. Now let's find out the z-scores. So z-score for 273 is, we know, is 0. So z is equal to x bar minus mu over sigma divided by square root of n. So we have all the numbers now. So this is 289 minus 273 divided by sigma is 100 and n, small n, or the sample size is 30, so square root of 30. So this is equal to 0.88. So this is 0.88 here, and so therefore this would be minus 0.88. Okay, so we need to find out the area between z-score of minus 0.88 and plus 0.88. Okay, so if you look up the probability tables, and I'm going to open the probability tables as well. So go up to the z-scores. Okay, and then what you would find is that for z-score of negative 0.88, is going to be 0.1894. So this area is 0.1894, and if this area is 0.1894, then this area is also going to be 0.1894. So then the central area is going to be, so probability that z-score is between negative 0.88 and positive 0.88 is equal to 1 minus twice 0.1894. So this is equal to 1 minus 0.1894 times 2, 1 minus 0.3788, and that's going to be equal to 0.6212. So that is the answer for part A. Okay, and then let's go to part B. Part B is, what is the probability that the mean price for a sample of 50 federal income tax returns is within $60? So now the only thing that has changed is our sample size. Now it has gone up. It's gone up to 50. Rest everything else is same. So what's going to happen is that we still want to find between 289 and 257, still this area. But now what's going to happen is that the z-scores will change because the sample size is changed. So z is equal to x bar minus mu over sigma divided by square root of n. Let's say x bar is 289, mu is 273 as before, sigma is 100 as before, but now n is 50. So z is going to be 289 minus 273 divided by 100 divided by square root of 50. So this, when we solve this, is equal to 1.13. So this z-score is 1.13, and so this is negative 1.13. Okay, and so now we need to find for the, if you go back to the z tables and look up negative 1.13, so the area on the left of negative 1.13 is going to be, so this is going to be 0.1292, and so this is also going to be 0.1292. So probability that x bar is between 257 and 289 is the same as probability that the z-score is between negative 1.13 and positive 1.13. So that is equal to 1 minus twice 0.1292, obviously because we want to find the area in the center, and then the answer is, let me just use my calculator, 0.7416. Okay, I'm just going to get some water here. Okay, so that is 0.7416. Now, in part C, if you go through part C, it says, what is the probability that the mean price for a sample of 100 federal income tax returns is within $60 of the population mean? So the only thing that's changing is now sample size, so n is 100. So what I would suggest is look at how we did part A and part B. And I have posted the answers or the solution set on Blackboard. So have a look at part C, but try to solve it on your own, because as you know, when we increase the sample size, your z-score should change. And so the new z-score, so if we draw the curve again, so 273, 289 and 257, we need to find out this area. So if you find the calculate the new z-scores, so this should come to 1.60 and this is negative 1.60. So, and then your answer should be, so probability that x bar is between 257 and 289 is equal to probability that the z-score is between negative 1.60 and positive 1.60, and you should get an answer of 0.8904. Okay, now let's look at part D. Which, if any, of the sample sizes in part A, B, and C would you recommend to ensure at least a 0.95 probability that the sample mean is within $16 of the population mean? Now, if you look at part A, part B, part C, so in part A, our sample size was 30, part B, the sample size was 50, and part C, the sample size was 100. And what happened was that the probability in part A was 0.6212, in part B 0.7416, and in part C 0.8904. But in none of the parts do we get a probability of 0.95? So we would need a bigger sample than n equals to 100, obviously, right? Because even n equals to 100 gives us a probability of only 89%. So for 95%, we have to go to a higher sample size. Now, before we move on, a couple of things I wanted to discuss here. Number one, as sample size increases, you would see that your standard error goes down and the probability goes up. So if you go from part A, B to C, you will see that as the sample size increases, the standard error is decreasing and the probability is going up. So everything is good. Error is decreasing and the probability is going up. Okay, one more thing before we move on to the next question. So if we look at chapter 6 notes, then the Z formula that we were using was Z equal to X minus mu over sigma. When we come to chapter 7, the formula that we are using is Z equals to X bar minus mu over sigma divided by square root of n. Now the question is, how would you decide which formula to use? Because if you are not told that the question is from a certain chapter, then how would you know whether to use um, the formula from chapter 6 or the one from chapter 7? So here's what I would suggest. If the question gives you, if the sample size is given to you, or the question mentions the word sampling distribution, I would suggest that you use this formula, and it will be a better formula than, or it would be, so it would be more appropriate than the formula that we learned in chapter 6. Okay, so let's move on. To question number 33. I'm just opening it on my slides. Just give me a moment here, please. Okay, question number 33 is saying, assume that the population proportion is 0.55. So assume that the population proportion is 0.55. So small p is 0.55. Compute the standard error of the population, or compute the standard error of the proportion sigma p bar for sample sizes of 100, 200, 500, 1000. What can you say about the size of the standard error of the proportion as the sample size is increased? So we are given n equals 100, 200, 500, and 1000. Now note that the population size is not given to us, and we are going to, therefore we are going to assume that the population size is infinite, and we are going to use this formula. So sigma p bar is equal to p1 minus p divided by n, and p is given to us as 0.55. So this is 0.55 times 1 minus 0.55 divided by n, and in this case n is 100. So if you solve this, you get 0.0497. Okay, and then when n is equal to 200, you can solve it. you get sigma p bar is going to be 0.0352, 0.0352. Similarly, when n is equal to 500, sigma p bar is going to be equal to 0.0222. And finally, when n is equal to 1000, sigma p bar is equal to 0.0157. So obviously what is happening is, as sample size increases, the standard error goes down. And this is exactly what we also saw in the previous question. Okay, so let's move on to the next one now, which is question number 39. Okay. So question number 39 is saying, Better Business Bureau complaints. In 2016, the Better Business Bureau settled 80% of the complaints they received in the US. Suppose you have been hired by the Better Business Bureau to investigate the complaints they received this year involving new car dealers. You plan to select a sample of car dealer complaints to estimate the proportion of complaints the Better Business Bureau is able to settle. Assume that the population proportion of complaints settled for new car dealers is 0.8, the same as the over proportion in 2016. So what we are given is P is 0.80. Okay, let's look at part A. Suppose you select a sample of 200 complaints involving new car dealers. Show the sampling distribution of P bar. Okay, so now n is equal to, small n, or sample size is equal to 200. So n times p is 200 times 0.80, which is equal to 160, and n times 1 minus p is equal to 200 times 0.20, which is 40. Okay, so because so if you go back, let me just look at the slide number. So if you go back to slide number 40, it says that whenever n, let me erase that, whenever n times p is more than equal to 5 and n times 1 minus p is more than equal to 5, we can use a normal distribution to estimate the proportions. So yes, so because they're both more than 5, so we can use the normal distribution. So we can say P bar is normally distributed with um, with expected value, or the average value, being 0.80, the same as is given here. And now let's find out the standard error. Oops, sorry. The standard error is sigma p bar is equal to p times 1 minus p divided by n. So 0.80 times 1 minus 0.80 divided by 200, the sample size. If you solve this, you get 0.0283. So again, p bar is normally distributed with the expected value equals 0.80 and the standard error equals 0.0283. Okay, let's go to part B. Part B is based upon a sample of 200 complaints, what is the probability that the sample proportion will be within 0.04 of the population proportion? Okay, so what is the okay, so basically what we are saying is that the average value is 0.80. So what is the probability that it is between 0.84 and 0.76? So obviously we need to find the z-scores. So z is equal to p bar minus p divided by the standard error, which we've already found. So this is 0.84 minus 0.80 divided by 0.0283. So if you solve this, you get 1.41. So this is 1.41, and then so these are the z-scores, and this is negative 1.41. Okay, so now let's look up the z table. So if you look up the z table, sorry, I'm not able to show you the tables as my software only allows me to open one screen at a time. But if you go back to the z tables and look for a negative score of 1.41, you would find that the area to the left is um, 0.0793, and so this is also 0.0793. So probability that p bar is between 0.76 and 0.84 is the same as probability that the z-score is between negative 1.41 and positive 1.41, and if you and this is equal to excuse me, yeah, so this is equal to 1 minus twice 0.0793, and the answer is, I'm going to just calculate it in my computer. So this would be 0.0793 into 2. So 1 minus 0.1586 equals 0.8414. Okay, so that's the answer. Okay, then part C. Suppose you select a sample of 450. Show the sampling distribution. Well, just like part A, so n is now 450. So n times p is 450 times 0.80 is equal to 360, and n times 1 minus p is equal to 450 times 1 minus 0.80 equals 90. So they are both more than equal to 5. So what we can say is p bar is normally distributed just like part A with expected value equal to 0.80, and sigma p bar, the standard error, is equal to p1 minus p divided by n. So this is 0.80 times 0.20 divided by 450, and the answer is so the standard error is 0.0189. Okay, Part D, based upon the smaller sample of only, or basically complaint, the sample size going up, sample of 450 complaints, what's the probability that the sample proportion will be within 0.04 of the population proportion? So the only thing that's changed between part B and part D is that the sample size now is 450. So just do it as we did part B. What you would find is that the new z-score is 2.12, and basically this is 0.80, 0.84, 0.76. So this is p bar, and now the z-scores is 0, so it's 2.12 and negative 2.12. So we are looking at this area, and the answer will be 0.9660. Okay, so do try to solve it on your own and see if you get the same answer. As measured by, so part E, as measured by the increase in probability, how much do you gain in precision by taking the larger sample? So when we increase the sample size from 200 to 450, what happens is that the probability increases. So in part B, we found the probability to be 0.8414. So from 0.8414 to 0.9660. Okay, so good. Let's move on to the next question, which is going to be the last question in this chapter. So that is question number 49. So that is landline telephone service. According to the US Department of Health and Human Services, only 49.2% of homes in the US used landline telephone service in 2017. Okay. So P bar is 49.2% or 0.492. Okay. Now let's look at part A. Suppose a sample of 207,000 US homes will be taken to learn about home telephone usage. Show the sampling distribution of P bar, where P bar is the sample proportion of homes that use the landline phone service. So N is equal to 207,000. So again, we use the same thing as in the previous question. So N times P is 207,000 times 0.492, which is equal to 101,844, and then N times 1 minus P is 207,000 times 0.508, and that is equal to 105,156. So they are both more than equal to 5. So we can say sampling distribution of P bar is normal with the expected value being 0.492, and standard error sigma P bar is equal to P times 1 minus P divided by N. So this is equal to square root of 0.492 1 minus 0.492 divided by n is 207,000, and that is equal to 0.0011. So that is the standard error. Okay, let's go to part B. What is the probability that the sample proportion in part A will be within plus minus 0.002? So if this is 0.492, so within 0.002 means this will be 0.494, and then this will be 0.490. So we are looking at this area. So obviously, as we have done before, so this is p bar. Let's find the z-scores. So let's find the z-score for 0.494. So z-score is p bar minus p divided by the standard error. So p bar is 0.494 minus p is 0.492 divided by the standard error, which we just found in part A, is 0.0011. So this comes to z-score of 1.82. So if this is 1.82, then this is negative 1.82. Okay. Now if you look up the z-scores, the z-table, you will find the area to the left of negative 1.82 is 0.0344. So then this means that area here will also be 0.0344. So probability that p bar is between 0.490 and 0.494 is the same as probability that the z-score is between negative 1.82 and positive 1.82. So this is equal to 1 minus twice 0.0344, right? So, and then that is equal to 0.9322. So that is the answer. Okay, now part C, the only thing that is changing in part C is that we have a lower sample size. So say part C says, suppose a sample of 86,800 entrepreneurs will be taken to learn about home telephone usage. Show the sampling distribution of P bar, where P bar is the sample proportion of homes that use landline phone service. So N is now smaller, it's 86,800. So just go through part A, see how we did part A, and similarly you will do part C, and you will find that in part C you can say that P bar is normally distributed with expected value 0.492 and standard error, so you calculate the new standard error, equals 0.0017. Okay, and then last part D, there is another one. Part D, what is the probability that the sample proportion in part C will be within plus minus 0.002? So again, it's the same as in part B. So this is 0.492, 0.494, and then 0.490. So you find the new z-scores because the sample size has changed, and you will find that the new z-scores are negative 1.18 and positive 1.18, and this should be 0.1190, and this area is 0.1190 as well. So probability that P bar is between 0.490 and 0.494 is the same as probability that the z-score is between negative 1.18 and positive 1.18, and if you solve this you should get 0.7620. So the probability has gone down because the sample size decreased. So probability decreased as the sample size went down or became smaller. Okay, part E, last one, is also saying, are the probabilities different in part B and D? Why or why not? Yes, they are different because the sample sizes are different, right? So as we saw, probability decreased as the sample size went down. Okay, so I believe with that we have finished all the questions that I listed at the back of chapter 7 slides. So what you can do now is you can try some of the other questions that I have asked you to try at home by yourself, and you can also do the WebAssign questions. Okay, good luck. Bye.